Pre-statistics. Scattergrams and exact linear relationships. Lesson objectives. Identify the independent and dependent variable in a given situation. Draw a scattergram involving independent and dependent variables. Lesson objective number 1. Independent and dependent variables. Assume that a authentic situation can be described by using the variables t and p, and assume that p depends upon t. Then we call t the independent variable. We call p the dependent variable. The variable that you can change is called the independent variable. The variable that changes as a result of the changes you made is called the independent variable. Normally, the variable you can control is the independent variable, and the variable that's out of your control is the dependent variable. Example 1. In each situation, identify the independent variable and the dependent variable. Number 1. Let L be the loudness, measured in decimals, of a sound produced by a foghorn that is d miles away from you. Number 2. A car is traveling at a speed s in miles per hour on a dry asphalt road. The brakes are suddenly applied. Let d be the stopping distance measured in feet. For number 1, the further you're away from the foghorn, the softer the sound you will hear. So the loudness, L, depends upon the distance, d. Thus, L is the dependent variable and d is the independent. Now notice that distance does not depend on loudness. Number 2, the greater the traveling speed, the greater the stopping distance will be. So stopping distance d depends upon the traveling speed s. Thus d is the dependent variable and s is the independent. Notice that traveling speed does not depend on stopping distance. Let's try this. Consider the two variables. How drunk a person is measured by the blood alcohol concentration, or BAC for short, and the number of alcohol drinks a person has. What is the independent and dependent variables? So if we think about this, the more alcoholic drinks that a person has, the more the blood alcohol concentration will go up. So the independent variable would be the number of drinks. The dependent would be the BAC. If we are given a BAC, we can't work backwards and determine the number of drinks because, say for example, gender has an effect on the BAC. For an ordered pair AB, we write the value of the independent in the first position and the value of the dependent variable in the second position. So for example, if we use the previous example, our order pair would be the number of drinks, comma, BAC. Thus, if we are given one data point, order pairs 5 and 1.1%, this would mean that a person has 5 drinks that produces a blood alcohol concentration of 1.1%. Lesson objective number 2. The average ticket prices for the Super Bowl are shown in the following table on the next slide for various years. Let P be the average ticket price in dollars and N be the Super Bowl number. Number 1, construct a scattergram of the data. Number 2, for what Super Bowls described in table 5 will have the highest average ticket price? What was the price? And number 3, describe any patterns you see in the prices. Let's look at the raw data. So here we have table 5. This is the Super Bowl numbers, our independent variable. Here's average ticket price measured in dollars, our dependent variable. And what we're going to do in the scattergram is look at the relationship between these two variables. P is the independent variable. Price depends upon the Super Bowl number, and P is on the vertical axis. Here we have our units, dollars. On the horizontal axis is our independent variable N, Super Bowl number. And if we take each order pair and we plot them, this is the graph that we get. And we call this a scattergram. So each point tells us a Super Bowl number and a corresponding price. For number 2, for the Super Bowls described in this table, what is the highest average ticket price? Well, we can see that that's $850, and that was Super Bowl 43. Number 3, from both the table and the graph, we can see that the average ticket price has increased. And we can also see that this increase is increasing at a faster rate. The differences between consecutive points, the Y, is getting larger and larger and larger. So what we would say is not only this is increasing, it's increasing at an increasing rate. We can also graph scattergrams by using the TI-83 or 84 calculator. There is a video that illustrates how to use the TI-83 calculator to produce scattergrams. Example 3. A life expectancy is the prediction of how long a person will live. The table on the next slide shows the life expectancies at birth for Americans in various years. Let L be the life expectancy at birth, measured in years, for an American born 2 years after 1980. Number 1, construct a scattergram of the data. Number 2, describe any patterns in life expectancy of Americans. Let's look at the raw data. Table 8, years of birth. We have from 1980 to 2006. Life expectancy measured in years is given here. So we'll be doing this many times in this course. We are going to take this date and we're going to count the number of years beyond 1980. And we're going to call that variable T. T will be our independent variable and L will be our dependent variable. First, we want to make a list of the values of T. For example, T equals 0 represents 1980 because 1980 is 0 years after 1980. When T is 5, that represents 1985. T is 10, that represents 1990. L is the dependent variable. The vertical axis is the L axis. We'll use a zigzag line on the L axis to indicate that part of the axis between 0 and about 71 is not displayed. This is done so we can show a clear view of the data points without having to make the coordinate system exceedingly tall. So right here is our little zigzag line, and this just shows that there's a break in this scale. And we do this because the lowest Y value we have is 73.7. So whenever you see this zigzag, that's just to indicate to the reader of the graph part of the axis is not displayed. So this is our scattergram. So to answer our last question, we can see from the scattergram that life expectancy has been steadily increasing. Now this is to illustrate what the same data would look like if we did not use the zigzag lines. If we just plotted from 0 to our first data point, we see that this almost looks like a horizontal line. Thanks for watching.